In this video, we're going to have a look at the inverse trig functions. So the inverse function for sine, for cos, and for tan. So first question is, when can a function have an inverse? Well, we talked the other day and we said when it's a one-to-one function. So let's have a look at the trig functions, and first of all we'll have a look at sine x. Now we can see that sine x isn't a one-to-one function, it's a many-to-one function. So let's see if we can restrict the domain so that it is a one-to-one function. So I've got a box here, and if I move my box over to around here, we can see that now we have got a one-to-one function, and that goes from where x is pi over 2 back down to where x is minus pi over 2. So we've restricted the domain to pi over 2 and minus pi over 2. And our range goes from 1 to minus 1. So let's have a look at the graph of that. So I've got here plotted y equals sine x, and we said that we're going to restrict the domain, so let's do that. So I'm going to go here, so we're going to start the x at minus pi over 2, and we're going to go to pi over 2. So there we've restricted the domain, and we also know that the inverse function is a reflection of this in the line y equals x. Now the graph software does that for us, so it reflects it in the line y equals x, and we'll put in the reflection axis. And there we are, that's our inverse function. So it sort of goes up like this through 0, 0, and then goes down. So let's have a closer look at that over here. So that's our inverse function. Now I'm just going to draw it again on the grid here to make it a bit clearer of the shape of that graph. So if I draw that, so it sort of comes down a little bit like this. Perhaps that's not very good. I'll try that one again. So it comes down like that, and then it sort of goes down the other way. So that's the general shape of our inverse function for sine. And what do we call the inverse trig function? So it's the inverse sine in this case. We call it arc sine. So y equals arc sine x is our inverse function. Now we also said about the inverse function that we swap over the domain and the range. So for our inverse function, y equals arc sine x, what's the domain? Well, if we remember, the range for our sine function was minus 1 to 1, so the domain must be minus 1 to 1. So we could put that in, so minus 1 to 1. So that's our domain, so I'm going to put that in here. So minus 1 to 1, and the domain for our sine function was minus pi over 2 to pi over 2. So the range for our inverse function must be pi over 2 to minus pi over 2. So that's from here to here. So let's put those in. So that's minus pi over 2 up to pi over 2. So that's our inverse sine function, or arc sine. Now let's have a look now at cos. So this is our cos function, and again we can see it's a many-to-one function, so we need to restrict the domain so we get a one-to-one function. So let's move our box, and we can see that around this point here we've now got a one-to-one function. So where does the domain go? Well, the domain starts at 0 and it goes to pi. So that's going to be our restricted domain, and we can see the range goes from 1 to minus 1 again. So let's have a look at the graph software. We were looking at sine before, so let's change that to cos. So we're going to look at cos x, and let's restrict our domain, and we said we're going to go from 0 to pi. So it's okay. That's so we'll just move that over here so we can see it. So that's our sine cos function rather. And let's do the same thing. Let's reflect that in the line y equals x. So if I click on that and let's reflect it, and we'll keep in the reflection axis, and there we are. So let's bring that down a little bit so we can see, and might be a good idea to make it a bit smaller. So there we are. That's our cos function, and this is our inverse cos function. So it's going from 0 up to pi, and then the domain will be 1 to -1. So that's the shape of the inverse function. So let's go back and have a look at that. So there's our inverse function. And what's it called? Well, if the previous one was arcsine, this one's going to be arc cos. So I'll just change that to arc cos. And what's our domain? And what's our range? Well, the domain is along here, and the domain's going to be -1 to 1, and the range goes from 0 up to pi. So there we are, inverse function is 0 to pi. Now the last one to look at is the tan function. Now we can see that the tan function is just a repetition of this shape here. And so our domain here goes from where the asymptotes are at pi over 2 and minus pi over 2. So let's have a look at that on the graph. So I'm going to use another one here, and I've already put in the inverse function. So the red one is the tan, and I've got an asymptote at pi over 2 and another asymptote at minus pi over 2. So when we've reflected it in the line y equals x, we get this green curve. Now the green curve will have a horizontal asymptote at y equals pi over 2. So I'll put that one in. So y equals pi over 2. And it's also going to have a horizontal asymptote at minus pi over 2. So I'll put that one in, y equals minus pi over 2 over here. So that's the shape of our inverse function. Now if we go back and have another look at that, so we've got the original tan, which is in red, and the inverse, which is in green. So let's draw that on this axis here just to make it a bit clearer. So our inverse function, it sort of starts off at 0 and it goes along the asymptote, and then underneath must do the same thing, so comes up like that. So that's the shape of our inverse tan function, and the same as the other ones, let's call it arctan. So y equals arctan x. Now what about the domain for that? Well, we can see that this is going along the asymptote, but it's going to carry on the asymptote up to infinity, and then going backwards it's going to go to minus infinity. So the domain will be all the real numbers. The range is restricted though, so the highest point for the range will be pi over 2, and the lowest point will be minus pi over 2. Now I've got a slight error here, so it's not equal to pi over 2, it's just less than pi over 2. So I'll perhaps put that in I'll just draw that in. So we've just got the less than rather than less than or equal to. Now let's have a look at a question connected with the inverse trig functions. So let's say we've got y equals arcsine x. We want to find cos y, and we want to find cos y in terms of x. I'll write that in over here, so in terms of x. So how do we do that? Well, first of all, let's do the inverse of that. So if y equals arcsine x, then x must be equal to sine y. Now, sine y means that the y is the angle in our triangle. So I'm going to put that y into there. And if sine y is x, we know that sine y is the opposite divided by the hypotenuse. So x is the same as x divided by 1. So the opposite must be x, and the hypotenuse must be 1. So using Pythagoras now, we know that this length squared plus this length squared equals this length squared. So the unknown length here must be equal to 1 squared minus x squared, and then square root the answer. So we've got root 1 minus x squared. Now we're asked to find cos y. So using the triangle, cos y is the adjacent divided by the hypotenuse, which is this. But because we're dividing by 1, we can just write it as this. So there we found cos y in terms of x. Now for homework, I would like you to do a similar thing, but this time, if y equals arc cos x, can you find sine of y? And I'm going to add to that, can you find sine of y in terms of x? And secondly, for homework, I'd like you to find arc cos of this, arc sine of this. So just using the arc sine, arc tan, arc cos, I'd like you to answer these questions. I'd like you to hand those in the next lesson.